Hello everyone, this is Meshari, a pharmacy intern at King Saud University. I will present my project which talks about optimization of vancomycin dosing regimen in cancer patients using pharmacokinetic pharmacodynamic modeling. First of all, cancer patients at high risk to get gram-positive bacterial infections, which are considered one of the major causes of mortality and morbidity in cancer patients. And an inappropriate vancomycin exposure is associated with toxicity, pathogen resistance, and therapeutic failure. We aimed in this study to estimate vancomycin pharmacokinetic in cancer and non-cancer patients. And then we evaluate the standard dosage regimen of vancomycin using data from pharmacokinetic modeling. The study was a retrospective matched cohort study, including cancer and non-cancer patients, and the data were collected from King Saud University Medical City. Patients should be older than or equal 18 years of age and treated with IV vancomycin for more than 2 days and have at least one vancomycin plasma concentration. And for exclusion criteria, patients who received a single dose of vancomycin and patients with renal or liver impairment, also dialysis patients excluded. For vancomycin administration and sampling, IV infusion of vancomycin over 60 minutes BID and trough level drawn just before the administration of the fourth dose and monitoring of vancomycin concentration to maintain trough of 10 to 20 mg per L. And the vancomycin model was developed using Monelex 4.4, and pharmacokinetic parameters were compared in both groups, and the standard and suggested vancomycin doses regimens were evaluated. For the results part, this table, the first one shows the demographics and characteristics of patients, and the second table shows the significantly increasing of clearance of vancomycin in cancer patients, which was 7.4 and 5.6 for non-cancer patients, and without any significance of volume of distribution. For the figure number 1, godness of fit plots obtained from the final model for vancomycin. For the figure A, we can see the relationship between observed vancomycin concentration versus population predicted vancomycin concentration and versus individual predicted vancomycin concentration for figure B, and the relationship between weighted residual versus time since last dose, we can see it in figure C, and versus population predicted vancomycin concentration for figure D. And the figure number 2, it measures the accuracy of godness of it and the predicted corrected visual predictive check for vancomycin concentration versus time based on 1,000 Monte Carlo simulations. And the solid black line represents the 10th and 50th and 90th percentiles of observed data. And the shaded regions represent the 90% confidence interval around the 10th and 50th and 90th percentiles of the simulated data. And the observed plasma concentration are represented by blue circles. For the figure number 3, the target attainment analysis for vancomycin AUC over MIC and should be more than 400 for various dosing regimens at different MIC values. As we can see clearly, when the MIC goes higher, the achievement of target will be decreased. For the conclusions, the findings of this study showed that the patients with cancer have lower levels of vancomycin due to higher clearance than non-cancer patients. Thus, higher doses than the standard vancomycin doses may be needed to treat invasive methicillin-resistant Staphylococcus aureus in patients with cancer. And the references and published paper will be in this barcode. Thank you so much for listening and attendance.